All right, so factoring quadratics, lesson 2. So the first thing we want to look at is factoring or finding the factors of the expression 2x squared plus 12x subtract 14. So we want to find the factors of it. So the first thing you should always look for, what? Well, yeah, the GCF. So we should look for the GCF first. Is there a GCF between 2x squared, positive 12x, and negative 14? The answer to that is yes. GCF is 2. GCF. So we recognize that, we should use that fact. So my GCF is 2, I can factor out of 2, which would mean divide each term by 2. You divide each of those terms by 2, you have the first term divided by 2, second term divided by 2, last term divided by 2. Meaning that it's going to be 2 times x squared plus 6x subtract 7. If you're pretty good at recognizing all those divided by 2, and you can go straight to this line, I'm perfectly okay with that. You don't have to show this line if you're understanding that you're dividing each term by when you're factoring out a GCF. So I got this, 2 times x squared plus 6x subtract 7. Now, then I'll decide whether or not this is a trinomial that I can factor. So now I'm looking at this and deciding whether the two numbers multiplied together to be negative 7 and add to be 6. And I think you can find a pair. So we think about this using the x method. This coefficient is 1, so 1 times negative 7 is negative 7. B value is 6, so that's 6. And we look for all the factors of negative 7, 1 and 7. And those are the only factors of negative 7. So it's got to be those two if it's going to work. Now I do know this. I know I got unlike signs, so one's positive, one is negative, and my bigger one is positive, right? So my bigger one is positive, and no 7 is positive. I know that since they're unlike signs, this one must be negative. If you think of it, negative 1 plus a positive 7 is definitely 6. And negative 1 times 7 is definitely negative 7. So now my factors are 2 times x subtract 1, x plus 7. If you forward that together, you should see that it does give you this. And it works. So that's what the solution is. Well, I'm sorry, those are the factors of that polynomial, right? So that's one where the GCF came in handy to recognize it right away. Go pause the video, get that as a note. I'll give you another one along the same lines. So consider this one. Take a minute, pause the video, use the exact same process I used last time. Try to factor it on your own. So take a minute, pause the video, actually try to factor this one on your own. If you pause it, you might recognize the GCF. 5x. You divide that by 5x, you're left with x squared. Divide this by 5x, you're left with positive 4x. Divide this by 5x, you're left with positive 4. So now we have a trinomial. Now the question is, can we factor this trinomial? And truthfully, instead of using the whole x, we can really kind of get to a point where we can just look at these numbers. And the question is, what multiplies to be this number, adds to be this number. So we look for numbers multiplied to be 4 and add to be 2. So if I was sitting in the 9th or 10th grade, I would be looking for ways that, help me out with this process. So one thing I can figure out is always going to start off with x and x. I got that out of the way. Also, this is a plus sign, so I can know I have like signs. So whatever these signs are, they both can be the same thing. And also it's nice to point out that this is the sign of my largest number. So my biggest one is positive. But since they're like, they both got to be positive. So got that much out of the way. Now the question is, what are the numbers I need here? So the question is, what numbers multiply to be 4 and add to be 4? Well, you might know that's 2 and 2. Meaning that x plus 2 times x plus 2 should give me that trinomial. And it works. That's what it is. You can fold it together, you can see that it really does work. So our final answer for it is this. All right, so that's what factoring all is about. You look for GCF, and then after you look for GCF, you look to see if you can factor it further. All right, give you another one, just like it, but slightly different. All right, so this example says factor quadratic expression. This is a negative sign, so negative x squared, subtract 6x plus 7. So in doing this, the first thing you want to look for is, what is GCF? So you're looking for that, and you look for a GCF there. Is there a GCF? You might say no. However, if you look closely, this x squared has a coefficient on it, which is negative 1. generally do not want that to be -1. You never want it to be a negative. You always want this leading coefficient to be positive. So if this leading coefficient is negative, you should treat that as a GCF. So your GCF here is -1. So if that's the case, we'll factor out a -1 from each one of those. The factor out a -1 from each one of those essentially changes each one of the signs. So when I factor out a -1, it means -1 times positive x squared, and a positive 6x, and a -7. I can prove it by dividing each term by it, and you'll see you come up with these numbers. So now the leading coefficient is a +1 here, which is great, because now I can look at this, I can decide whether or not I can factor it. So let's use what we just learned last time. Pause the video and actually try to factor it the way I did without the x, and simply using 2 sets of parentheses. Pause the video and go try that now. Probably recognize is going to be x and x. Probably also recognize got unlike signs, so one's positive and one is negative. Biggest one is positive, and I got to look for something that multiplies to be 7 and adds to be 6. Well, that's 7 and 1, so I need a 7 and I need a 1, and the 7 is bigger, so it goes over there. And this would be the answer for it. Got it? Pretty easy stuff. Now we're going to throw a little loop in your system. Everything you know, we're going to add to it. So pause the video and I can add new to it. Okay, so it's factor the expression 2x squared plus 17x, subtract 9. So you're looking for a GCF, right? Do you see one? And 2x squared and 17x and a -9. Probably there's a no, because 17 is prime, so 2 can't go into it. So you can't factor out a number, and all those variables, you don't have a variable in common. This 9 doesn't have a variable. So it has no variables in common. So up until now, we have no way of factoring this because it does not fit the description of factoring out a GCF, nor is the leading coefficient a +1 here. Remember we said earlier, the method we have been using only works when it's leading coefficient +1. So it isn't a +1. So this is a problem. In this case, a is greater than 1. So when this happens, we have to do it a different way. We have to make it 1. How can we make it 1? We've got to cheat a little bit. Take this 2, multiply it to the 9, giving you this new polynomial. Positive x squared plus 17x, 2 times -9 is -18. Now, we look at this. Can we find two numbers multiply together to be -18 and add to be 17? Well, yeah, we can. If we went to the x, we'd want to have a -18 on top, and we have 17 on the bottom. And we think about all the numbers that multiply to be 18, add to be 17. 1 and 18. You really can stop there because that's going to work. Your positive 18 and -1 is going to work for you. So I need a -1 here, positive 18 here. So if you understood that, you think that the factors are x subtract 1 times x plus 18. However, you do have to remember that this should fall together to be, because remember these factors mean you multiply together to be a bigger number. This should multiply together to be what we began with. If you notice, it doesn't, because x times x gives you x squared. If you multiply those together right now, x times x would be x squared, not 2x squared. So it's a good sign that something's wrong. So because we began with an a value of 2 and multiplying at the back, whatever this a value is, whatever it is, in this case it's 2, we come back, we divide it by here in this step. You always have to remember this. It's forgotten a lot. Please don't forget it. Remember to come back and divide this part by 2. Now, whatever can reduce, you should reduce it. So x plus 18 over 2, this is reduced really nicely to be x plus 9. Perfect. Don't have to think about that anymore. Here is 1/2. Can't reduce 1/2. It's a simplified fraction. So because of that, we go bottoms up. This 2 comes up in front of the x as a coefficient. So now it says 2x. Let's subtract 1. Comes down. So now I know that the factors are 2x subtract 1 times x plus 9. If you check it, it should work. So I'm going to find some space just to check it, just to make sure it works. But I'm thinking the factors are 2x subtract 1 times x plus 9. So let's check it. So 2x times x is 2x squared. 2x times 9 is positive 18x. Negative 1 times x is a negative 1x. Negative 1 times positive 9 is a negative 9. 2x squared plus 0 is 2x squared. 18x's plus a negative 1x is a positive 17x. Subtract 9, which is exactly what we began with. So look at there. We have a new method that works. These are the factors. And the process of it was taking this 2, multiplying to the back, and it becomes something that we're very familiar with, because now the leading coefficient is 1. But you must remember to come back and divide by whatever that a value was. All right, so let's give you some more of those to try on your own. All right, I got 2 examples here. These are just for you. Pause the video, write them down, put a little space between them, and actually try each one. Just as you would if you understood I'd do this in class tomorrow. So right now, pause the video and give them a shot. If you gave it a shot, or if you're stuck, you should have recognized first that there are no GCFs. So you should have multiplied 7 times 7, making this x squared plus 50x plus 49. And if you're good with the x game, you probably stepped up 1 generation to going straight to these 2 binomials. And if you did that, if you skipped the x game step, you probably put an x and an x. And then you ask yourself, well, multiplies to be 49, and that'd be 50. Well, I got like signs, both positive. So 49 and 1 gives you 50. But don't forget, come back and divide each of these terms by 7. So 49 divided by 7 gives you 7. 1 7 does not reduce, so 7 comes bottoms up. So those are the factors, x plus 7 and 7x plus 1. And those should fall together to be the big beginning one. Have you tried the last? If not, go ahead and try it now. Those should multiply to be a negative 12, so x squared, subtract 1x, subtract 12. And now you ask yourself, well, what multiplies together to be 12? Adds together to be 1. Well, they're unlike signs, so one of them is positive, one of them is negative. And the numbers need to multiply to be 12, add to be 1. Think about all the factors of 12. Got 1 and 12, 2 and 6, 6, 3 and 4. Well, of all those, which one multiply together can add together to be 1? 1 and 12 can't, 2 and 6 can't, 3 and 4 can. And in this case, the biggest one is negative, so the 4's got to be the negative one. So this is negative, and the 3 is positive. Are you finished? Are those the final answers? Probably said no. You divide this by 2, divide that by 2. Why? Because you had a value of 2. And your final answer should be x subtract 2 in the first parentheses, and the second parentheses 2x plus 3. And there it is. That's how you factor them. So that's how you actually factor trinomials. That's all I have. Good luck.